Assalamu alaikum dear students. Today we are going to discuss few more examples on how to find the tangents and normals to the given curve. So question number 8 of this exercise is we have to find the points on this curve, that is the given curve is x minus 2 whole square, at which tangent is parallel to the chord joining the points 2 0 and 4 0. This means that we have to find the point on this or the points on this curve at which tangent is parallel to the chord joining the points 2 0 and 4 0. So this means that the slope of the tangent should be equals to here the slope of the chord joining the points 2 0 and 4 0, because tangent and this chord are parallel. Now here the slope of this chord is, that is the chord joining the points 2 0 and 4 0 is given by simply difference of y coordinates upon difference of x coordinates, that is simply 2. So the slope of the chord joining the points 2 0 and 4 0 is 2, which implies that the slope of the tangents or the tangent to the curve y equals to x minus whole square is 2, because by the condition of parallelism. Now the given curve is y equals to x minus 2 whole square. Now the slope of tangent at any point on this curve, that is xy, is given by dy by dx is 2 into x minus 2. Now points at which xy equals to the points of the form of xy at which the slope of tangent equals to 2 is given by dy by dx equals to 2, because slope of tangent is 2 and slope of tangent from the given curve is given by dy by dx at any point xy, which implies that when we substitute the value of dy by dx in this, we simply get x equals to 3. When x equals to 3 from given curve, that is when we substitute in y, we simply get y equals to 1. So when x is 3, y is 1. Hence the point 3 1 is the required point at which the tangent is parallel to the chord joining the points 2 0 and 4 0. Now another problem of this type: find the point on the curve y equals to x cube minus 11x plus 5 at which tangent is y equals to x minus 1 x minus 11. This means that here we have to find simply the point on the curve at which tangent is this, simply this y equals to x minus 11. Here given curve is y equals to x cube minus 11x plus 5. Now the slope of tangent at any point is given by derivative, by its derivative, that is dy by dx, which is 3x square minus 11. Now the given tangent is, because we have to find the points on the curve at which the tangent is y equals to x minus 11, which is of the form of y equals to mx plus c, because slope intercept form when we compare m equals to 1. So this means that the slope of tangent is here 1, which implies that slope of tangent is 1. Hence dy by dx, we have to find the point. So dy by dx is 1, because slope of tangent from derivative is given by dy by dx. When we substitute here, we get x square equals to 4 or x equals to plus minus 2. Now if x is 2, when we substitute the value of x equals to 2 in y, we get y equals to minus 9. Similarly, if x is minus 2, y equals to 19. Hence the points 2 and minus 9, minus 2 and 19 are the required points at which the tangent to the curve y equals to x cube minus 11x plus 5 is y equals to x minus 11. So these are the two required points. Similarly, find the equations of the lines. So we have to find the equations of lines whose slope is minus 1 and which are tangents to the curve y equals to 1 upon x minus 1. Given curve is y equals to 1 upon x minus 1. Now it is derivative by using the difference, this quotient rule of differentiation is simply given by dy by dx is minus 1 upon x minus 1 whole square. So this dy by dx is the slope of the tangent at any point, say at arbitrarily point x, y, which is minus 1 upon x minus 1 whole square. But it is given that we have to find the slopes of the lines having slopes. We have to find the equations of the lines having slopes equals to -1 and which are tangents to the curves, which implies that the slopes of the tangents or the tangent is -1, which implies that dy by dx is -1. Or when we substitute the value of dy by dx, we simply get x equals to 0 and x equals to 2. Now if x equals to 0, the corresponding point at x equals to 0, y is -1. Similarly, x equals to 2, y comes out to be 1. This means that these 2 points 0 and -1, 2 and 1 are the points at which the slopes of tangent is -1. Now when slopes is -1, this means that these 2 points 0 and -1, tangent passes through 0 and -1, while as another tangent passes through 2 and 1, but their slopes is same, that is -1. So we have to find the equations of tangent, means equations of lines. So substituting the in slope point form, because we have point through which a tangent passes and fixed slope or the finite slope, y minus y naught is m times x minus x naught. In first case we have to put m equals to -1, x naught equals to 0, y naught equals to -1. So when we substitute it, we simply get x plus y plus 1 equals to 0. So this is the required equations of the line which passes through 0 and -1 and having slope equals to -1. Similarly, when we put x naught equals to 2, y naught equals to 1, we get and m equals to -1, because we have to find the equations of lines. So simply when we substitute here in y minus y naught equals to m times x minus x naught, we simply get x plus y equals to 3. So these are the only two lines having slope equals to -1 and which are tangents to the curve y equals to 1 upon x minus 1. Now another problem of this type, find the equations of the lines with slopes 0. So equations of line slope of the line is 0 and which are tangents to the curve y equals to 1 upon x square minus 2x plus 3. Here slope of tangent at any point xy is given by differentiating the given curve, which is by using the quotient rule or using any rule of differentiation. We simply get minus 2x minus 2 upon x square minus 2x plus 3 whole square. So this is the derivative, or simply this is the slope of tangent at arbitrary point xy. Now it is given that we have to find the slope of tangent. So we have to find the equations of lines with slope 0 and which are tangents to the which are tangents to this curve. This means that slope of tangent is here 0. When we substitute here, we get x equals to 1. So x equals to 1, when x equals to 1, y becomes 1 upon 2. So 1 by 2 is the point at which the slope of tangent is 0. This means that that tangent means the line passes through 1 by 2 having slope 0. So by using the slope point form, y minus y naught equals to m times x minus x naught, we simply get y equals to 1 by 2. So y equals to 1 by 2 is the line which is tangent to the curve y equals to 1 upon x square minus 2x plus 3 having slope 0. So inshallah, in tomorrow's video lecture we will discuss few more problems, how to find the tangents and normals at a given point. So thank you.